In previous videos, in the past probably 4 videos, we've looked into the algebra warm-up exercises on Brilliant, and we've actually done these 4 concepts. So cryptograms, exponents, algebra shortcuts, and in the very most recent video, root warm-ups. And each of them have been interesting exercises, but what's more interesting is that today we're going to start doing the algebra challenges. And just to give you a sneak preview of what's to come on the channel, we are only on algebra warm-ups here, but if we go back, we also have properties of arithmetic, which have a lot of exercises to work through. And then so we've only been into the concepts practice. We have in expressions and variables, we also have solving equations, and then we have a lot of stuff in here. Common misconceptions, a lot of stuff in there as well. Linear equations, systems, absolute values, linear inequalities, and a lot of stuff that's only in the algebra practice here on Brilliant. But if we go back and we can see that was only algebra. We also have basic mathematics, calculus, chemistry, and all other interesting stuff. So there is a lot to come. The ultimate, one of the ultimate goals of these practices and series is to actually get a very good understanding of machine learning and deep learning concepts. As we progress through the algebra, we're also going to do some more theoretical videos because we want to understand the linear algebra behind deep learning and machine learning. And so we have the algebra here. We'll be looking into computer science, into the machine learning section at some point as well, maybe into programming languages as well, because here are probably very interesting exercises. So yeah, going back, it took a little while to start this video. Going back into our very beginnings, we'll just do the algebra warm-ups level 1 challenges today. So without further ado, let's start with the first one. So we have 2013 times 2014 minus 2013 times 1392. I think we actually did this in a previous video. So 2014 minus 1392. This is actually pretty simple because we're gonna, here on the top, we're actually gonna, let me pick a different color. We're gonna factor by 2013. So this is actually 2013 multiplied by 2014 minus 1392, and then this is gonna be over 2014 minus 1392, and this actually goes pretty nicely, and the result is 2013. So let's actually type it. 2013. There you go. Let modulus of x, so let me actually add the dividing line here. Okay, that's good enough. Let's change the colors. Is this visible? Yeah. So let modulo x be the answer to this question. Find the value of 1 over x. So this might be a bit tricky. We might probably look into the explanation or not. So modulus, let x be the answer to this question. Find the value of 1 over x. I don't think I understand what they actually request here. So modulus x, find the value of 1 over x. Do we actually have to make them equal? I'm not sure. I'm not actually sure what they want here. So let's first look into the wiki. So find all the values of x satisfying squaring both sides. Problem solving. Well, the instructions, maybe it's just me, but the instructions do not actually look really clear here. So let x be the answer to this question. Find the value of x. So if you let x be the answer, then find the value of 1 over x. And if we have the modulo x the answer, would have to actually 1 over x squared equals, so no, this is probably not what they're looking for. But let's see the explanation. What exactly do they want? So yeah, x equals 1 over x, therefore modulo x times x equals 1. What else? So the fellow here says that the only solution to this equation is 1. Yeah, and he's right actually, because, for example, if we take x as being 1, you have modulo 1 times 1 equals 1, and that's true. And if you would try to see if x equals minus 1, modulo of minus 1 is 1 times minus 1 would be minus 1. So minus 1 wouldn't be a solution. We can scratch it. And as this fellow over here said, the only solution would be x equals to 1. Well, still, the instructions were not clear. Or I am just trying to make up an excuse for not actually knowing what they want. Anyways, let's type 1. What is the value of n in the following expression? So we have, the idea here is to understand better. So 1 plus 2 plus 3 plus dot 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 plus n minus 1 plus n plus n minus 1 plus 3 plus 2 plus 1. We have no more real estate here, so we'd have to do a little bit of Samsung Notes Kung Fu. plus 3 plus 2 plus 1 equals to 289. So if we know some rules in algebra, this would actually be n over n plus 1, n times n plus 1 over 2, if I'm not mistaken. And then this over here we have some dots left out. So obviously I haven't done this before, which is why I'm actually trying to think of solutions as we speak. In this case, we could say plus, we go all the way up to n minus 1. So in this case, it would be n minus 1 times n over 2 equals to 289. Is it? So in this case, we'll have n over n plus 1 plus n minus 1 over 2 equals to 289, minus 1 with plus 1. Then let's just go on to the next page. So n times 2n over 2, we have 2, so equals to 289. We have n squared equals to 289, and n equals to 17. Is it? So 289, if I'm not mistaken, is the power of 17. 15 is 225, 16 is 246. Anyways, let's just plug in, what was it, 17 here? So 17. Dang. The assumption was correct. All right, moving on. Obviously, this is going to be a slightly lengthier video, but so far I am enjoying it and hope you're enjoying it as well. So we have square root of 3 minus pi plus, did they actually think we don't know that 3.14, 16, so 3.1416 is pi plus 1 million other decimals. So how do we evaluate this expression? 3 minus pi squared, we can simply do, so the square root of a square is the actual thing itself, but we could also do the multiplication. I think there are multiple ways to actually do this. Let's try the first one that comes to my mind. We could simply rewrite the first one as, so if we apply the rule of subtractions, I'm not even sure if that's what it's actually called. We have 3 minus 3.14 14. So this entire thing would be 3 minus 3.14, 3 plus 3.14, and then we'll have plus square root of 3.14 minus 3.14 plus 3. Okay. If we calculate this, this is minus 0.14 times 6.14. And in this case, 0.14 times 6.14. Obviously, this is probably not the best way to do it because this is still under the square, and we'd actually have to multiply these. So we could actually try a different approach. So this was approach number 1, and approach number 2 would be to actually apply the rule that the square root of something to the power of 2 is actually that something. So in this case would be 3 minus 3.14 plus, let's actually change the color here. Let's do some blue. So 3 minus 3.14 plus 3.14 minus 3. And in this case, it simply is minus 0.14 plus 0.14. So obviously we're not going the right direction. Because this is actually 0. And we have no 0 over here. Three minus 3.14. How should we go about it? We could go back to this and this, and if we do the multiplications, let me take a calculator. This is a brute force approach. So 0.14 times 6.14. This one would evaluate to 0.86. Actually minus 0.86, and this one would evaluate to 0.86. But in this case we have the square root of something negative times the square root of something positive. So what would the square root of minus 86 be? So minus 86 interesting. So let's actually look into the explanation over here. It kind of got me lost. So this fellow here says that's modulo. That's the assumption where we have to start. So in that case, we're gonna scratch everything we've done here. everything. And do it like that. So this would be modulo 3 minus 3.14 plus, a little bit disappointed here, 3.14 minus 3. Yeah. So this evaluates to 0.14 because inside it would be minus 0.14, but in modulus minus 0.14 is 0.14 plus 0.14, and it would be 0.28. Alrighty. So it's 0.28. I think this is the last one. So 2 to the power of 3 plus 2 to the power of 3 plus 3 to the power of 4 plus 3 to the power of 4 plus 3 to the power of 4 equals to what? So we have 2 to the power of 3 times 2 plus 3 to the power of 4 times 3. We can actually, we don't even have to apply gimmicks or any other things. This is 8 times 2, 16 plus 3 to the power of 4 is 81 times 3 equal to what? Equal to what? Is 16 plus 243 is equal to 259. 2 to the power of 3 to the power of 3, so 2 to the power of 3 times 2, right? And 3 to the power of 4 times 3. 81 times 3 is 243 plus 2 to the power of 3 times 2. Now, in this case, 259 should evaluate to one of these. 4 to the power of 5, no. 2 to the power of 3 to 3 to the power of 4. That's exactly what it is. So 2 to the power of 3 is 8. No, it's actually 2 to the power of 4 plus 3 to the power of 5. Because in this case, if we do it like this, from here, 2 to the power of 3 times 2, 2 to the power of 3 times 2 is equal, this can also be said that 2 to the power of 3 times 2 to the power of 1, and we just add these two, so it's 2 to the power of 4, and in this case is 3 to the power of 4 times 3 to the power of 1 is 3 to the power of 5. Therefore, what we have there is 2 to the power of 4 plus 3 to the power of 5. And there you go.